The generalized pigeonhole principle starts off just like the regular pigeonhole principle. We have n objects and we want to sort them into m boxes. Now, these two statements diverge in what they say about the resulting distribution, where the pigeonhole principle just says at least one box has to have more than one item. The generalized version gives us a little more detail. It says that there's at least one box that has to have at least this number, right? At least the ceiling of the number of objects divided by the number of categories, right? So let's look at an example here. Say we have 9 objects and we want to allocate them into 4 boxes, right? Well, the principle says if we look at these numbers, it's ceiling 9 divided by 4, which is whoops, not a bracket, ceiling. I really want to make that into a bracket. There we go. Ceiling 2.25, which is 3, right? So there may be some boxes that have more, and there may be some boxes that have less, but the statement is guaranteeing at least one box with at least 3 objects in it. You can see that pretty quickly for our example here. If you start trying to sort the objects into the boxes in such a way that the sizes are minimized, putting one object into each box leaves us with 5 objects. Now remember, we're trying to keep this to a minimum, right? So if we're going to put one more object in each box, that takes us to 2, and at this point we still have one left, right? So we have no option but to create at least one box that has the 3 elements that the principle says it's going to have. So let's look at a quick example here. We'll look at some somewhat more mathematical ones in the next lecture. If we have 100 people in a room, I want to know what's the smallest number that must have the same birth month. Well, obviously there's 12 options here, right? There's 12 months to choose from. And just like when we're using the basic pigeonhole principle, you always want to be thinking, okay, what are the pigeons and what are the holes? What are the objects and what are the categories? Right? Well, here it helps look at what you're being asked. Right? We're asked to find the number that have the same birth month. Okay, so it's the birth months that are going to be the categories, and it's the people that are going to be the objects, or the pigeons, if you will. So, what does the theorem say then? I always call it want to call it a theorem. The principle. What does the principle say? Well, if I put 100 objects divided by 12 categories, and we want the ceiling of that. Right, 100 divided by 12, that's 9 and a third, I think 9.333. We want not 9, excuse me, 8.333. So what's the ceiling of this? Well, it's 9, right? And there's my answer, right? There must be at least 9 people in that room, maybe more, right? Maybe more, who have the same birth month. Okay, so that's the basic idea, right, of this principle. So in the next lecture, we're going to look at a couple more examples that are a little more technical, mathematical ones.